Welcome to this exam-focused explainer on mastering the core control mechanisms in Java. We're going to break down exactly how you can bring structure and security to your code, focusing only on what's absolutely essential for your quizzes, assignments, and exams.
Okay, so let's get right into it. When you're building a simple program, it's pretty easy to keep track of everything. But as your application starts to grow, it can quickly turn into a tangled mess. So how do you manage all that complexity? Well, Java gives us three key tools to solve this exact problem: access modifiers, packages, and interfaces. Let's master them.
So, the first and most fundamental layer of control happens right down at the member level. We're talking your variables and your methods. This is where we use access modifiers to lay down a clear set of rules for who gets to see and use what. Okay, this table right here, this is your ultimate cheat sheet for exams, so let's walk through it real quick. Notice private is the easiest one. It only gets a yes in its own class. Simple. On the other end of the spectrum, you've got public, which gets a yes all the way across. The tricky ones, the ones that trip people up, are right in the middle. Default access is stuck inside its own package, while protected adds a special rule. It lets subclasses have access, even if they're in a totally different package. Nailing that distinction is absolutely key. Starting with the strictest of them all, private is your tool for maximum protection. When you declare something as private, it's like putting it in a locked vault. It is completely, totally inaccessible from outside its own class. This is the heart of what we call information hiding or encapsulation. So, what happens if you don't type any modifier at all? Well, Java applies what's called default access. You can also think of it as package private. It basically means the member is visible to any other class, but only if that class is in the exact same package. It's a really handy way to share code between classes that are closely related. Now, protected is all about inheritance. It follows the same rules as default access, but it has one extra superpower. It's also visible to any subclass, even if that subclass lives in a completely different package. This is absolutely essential when you're building frameworks that you want other people to be able to extend. And finally, we have public. This makes a class, a method, or a variable universally accessible from literally anywhere in your project, or even from other projects entirely. You need this for the main entry points of your application, your public APIs, but you really want to use it carefully to avoid exposing internal parts of your code that shouldn't be messed with. So that handles control for individual members. But now let's zoom out a bit. How do we organize entire groups of classes? Well, that's where packages come into the picture. A package is really just a namespace or, a folder for your source code. It solves two huge problems. First, it brings some order to the chaos by letting you group related classes together. And second, it prevents naming collisions. Two different programmers can both create a class called myClass with no issues as long as they're in different packages, like com.company1.myclass and com.company2.myclass. For your practical exams, you absolutely have to know these 4 steps. First, you declare the package at the very top of your Java file. It has to be the first line. Second, you have to put the compiled class file into a matching directory structure. Third, the class itself has to be declared public, otherwise it's invisible outside the package. And finally, you use the import statement to pull that class into any other file that needs it. And here is a classic exam day gotcha. How does Java even know where to find these package directories you've created? The answer is the class path. It's an environment variable that basically tells the Java virtual machine, hey, when you're looking for packages, start by searching in these root directories. Okay, so that brings us to our third and final layer of control. This one is less about hiding things and more about defining a strict contract of behavior. We're now entering the world of interfaces, which let us specify what a class must be able to do without saying a single word about how it should do it. This is a guaranteed exam question, so let's nail this down. A class extends an abstract class, which can be a mix of already implemented methods and abstract ones. But a class implements an interface, which is a pure contract of 100% abstract methods. That difference between partial and total abstraction is absolutely fundamental. To really lock this in for your exams, just burn these golden rules into your brain. The methods are public and abstract by default. You don't even have to type it. The variables are always constants. And remember, a class implements an interface. It doesn't extend it. That implements keyword is the magic that lets a single class adopt multiple contracts, which is Java's really powerful answer to the problem of multiple inheritance. All right, that was a lot of information. Let's make sure it all sticks with a quick fire review. I'm going to ask a typical exam question. You try to answer it in your head before I show you the next slide. Ready? Let's do this. First one up. Can you list the 4 access modifiers in order? Start with the one that gives you the most protection and go all the way to the one that provides the least. Did you get it? The correct order, from most restrictive to least, is private, then default, then protected, and finally public. Getting the order of default and protected right is a common exam trap, so be careful. Protected is slightly less restrictive because of that special inheritance rule. Okay, next question. Why do we even bother using packages in our projects? Think about the big problems they're designed to solve. Right, so packages really have 3 main jobs. They stop you from running into naming clashes, they help you organize your code into logical modules, and they provide that special package private level of access control with the default modifier. And for our final critical question, this one really tests your design sense. When is an interface not just another option, but your only choice over an abstract class? There are 2 huge scenarios where an interface is your only move. First, when you need to achieve multiple inheritance, because a class can implement as many interfaces as it wants. And second, when you need to define a common capability, like being comparable, that can be applied to a bunch of completely unrelated classes. And that's really the whole picture. When you master these 3 layers of control, access modifiers for your members, packages for your classes, and interfaces for your contracts, you're fully equipped to build large-scale, robust, and maintainable Java applications. Look, this gives you the power to design with intention. It's not just about getting the code to work, it's about making it clean, secure, and easy for you and others to maintain. So the next time you start a new project, think about how you'll apply this knowledge from day one. That's how you go from just being a coder to being a true software architect.